So with comparing functions, we're just comparing them in different forms. Okay, so this says we can compare functions by looking at their properties such as their slope or rate of change. Remember, slope, rate of change, unit rate, constant of proportionality, those are all the same things. We've talked about that all year. To find rate of change, use the slope formula. Okay, so remember that is your change in y over your change in x, or compare the ratio of y to x. Okay, so this is review, so we're just going to practice again. So find the rate of change. Okay, remember that when we have an equation that's in the form of y equals kx or y equals mx, then our rate of change is here, our slope is here, because remember these are the same. Okay, remember they are multiplied by the input, by your x variable. So the rate of change for this one would be 2/5, okay? Because it's saying that it's changing by 2/5 every time. Or as your y increases by 2, your x increases by 5. Okay. For number 2, then we're going to use the slope formula. So y minus y over x minus x. Okay. So 9 minus 7.5 over 6 minus 5. Okay. So then that gives me 1.5 over 1, which becomes 1.5. Okay, on number 3, we have a table. Okay, so we can just look here and say, well, our y decreased 6 and our x increased 2. So -6 divided by 2 is -3. And then on number 4, find the rate of change. So we just need to find 2 good corners. So like this right here is a good corner, and so is this. So my y increased 1 and my x increased 4. So remember it is y over x, so I get 1/4. Okay. Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. Okay, so Ty's rate is 7 signs every 2 hours. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in the table below. Okay, so we can see that 15 signs were made here, okay, over 4 hours. Okay, so we can simplify that if we want to, and we would get 7.5 over 2. Okay, so who is making signs at the greater rate? Well, 7.5 signs in 2 hours is more than 7 signs every 2 hours. So that means that Harrison is a little bit faster at making signs. Okay. The other way you could have compared that is to say that if Harrison is making 15 in 4 hours, then Ty has to be making 14 in 4 hours. After 12 hours, what would be the difference in the number of signs that each friend has made? So if we take Ty and we say he's making 7 in 2, right? That's 3.5 in 1. Okay, so 3.5 every hour. So if I take 3.5 and I multiply that by 12, then I would get 42. So that means in 12 hours, Ty can make 42 signs. Harrison, we said that he can make 3.75 signs per hour. So if we substitute 12 for our variable, because how many can he make in 12 hours? Okay, our input would be 12. Then when we multiply that, we get 45. So when it says what would be the difference, then they're asking after 12 hours, how many more signs would Harrison have made? Well, then we just need to subtract 45 minus 42, and we get 3 signs different. Okay, Harrison would have made 3 more signs after that amount of time. Julie's family is filling up the pool in her backyard. So this is the equation that can be used to show the rate at which the pool is filling up with water, where y is the total amount of water that's going to be in the pool after a certain amount of time. Okay, so her neighbor Elena is also filling up their pool as shown in the table. So the thing to do would be to go ahead and create an equation for Elena's rate. Okay, so after 0 amount of time, her pool already has 7,850 gallons in it. Okay, and then if we look after 3 minutes time, how much more water does the pool have? So if you subtract 7,864.4 minus 7,850, you will get that it has had an increase of 14.4 gallons in 3 minutes. So when you divide that by 3, then you get that hers is filling at a rate of 4.8 per minute. So then it says whose pool is filling at a faster rate? Well, Elena's is filling at 4.8 gallons per minute, and Julie's is 5.2 gallons per minute. So Julie's is filling faster. Julie, okay? Because 5.2 gallons per minute is greater than 4.8 gallons per minute. Compare the slope in each of the equations below. Circle the equation that has a greater rate of change. Okay, so what we need to do first is remember that to write an equation in slope-intercept form, it must be written as y equals mx plus b, okay, where m is your slope and b is your initial value, okay, or what you start with. So we need to change these equations, and we talked about this a little bit yesterday. So what I want to do is get my y's on one side by themselves. So I'm going to get rid of this x. So I'm going to add 9x to both sides, okay? When I do that, then I'm left with 3y equals 9x plus 27, okay? But what I want you to notice is that y has to be by itself. So in order to make that happen, I have to divide by 3. What I do to one side, I have to do to the other. So now I have that y equals 3x plus 9. Okay? So I'm going to do the same thing with my other equation. So I need to move my 3x by doing the opposite. So then I'm left with 4y equals 3x plus 24. So then I have to get y by itself. So I divide by 4. And what I do to one side, I do to the other. So now I can see that y equals 3 divided by 4. You're just going to say 3/4. X, 24 divided by 4 is 6. So then the question, it says circle the equation that has a greater rate of change or a greater slope. So notice that this is 3 and this is 3/4. 3 is more than 3/4. Okay? So then that would be the answer. Compare the slope in the equation, so we're on number 8, with the slope shown in the ordered pairs below. So we see the slope here, right, is 3/5. So then we have to find the slope in our ordered pairs. Okay, so you can use any. Remember, with ordered pairs, you're just going to say your change in y over your change in x. So y minus y, 6.2 minus 5. So then for our x's, we have 7 minus 5. So that leaves us with 1.2 over 2. Okay, so we can simplify that further and we get 0.6 over 1. Okay, so what I want you to notice is that we have 0.6 here and we have 3/5 here. Well, 3/5 written as a decimal is 6/10. So that means that they actually have the same rate of change. So we would say that it is the same. The rate of change is the same. Reese and Kevin have been working out together to try and lose weight. Reese's weight loss can be modeled by this equation, and Kevin's is shown in the graph. Okay, so we need to figure out what Kevin's is. We can make an equation for Kevin's. So we can see that Kevin his starting weight was 200. Okay, he started at 200 pounds. And we see that he's losing weight because we have a negative slope, okay? So we need to figure out how quickly he's losing weight. So remember, we can look at y decreased 20, meaning he dropped 20 pounds in 4 weeks' time. So this is a decrease of 5 pounds per week. So that is our rate of change. So the question we're asked is who is losing weight at a faster rate? Okay, so Reese is losing 4 pounds a week and Kevin is losing 5 pounds a week. So Kevin is losing weight at a faster rate, right? He is losing 5 pounds a week. Okay, and 5 is greater than 4. You can say that, but you don't have to say that. Okay, so the big thing is that Kevin is losing weight at a faster rate. Okay, so that's what we would compare and see. As always, please let me know if you have questions.